Hi friends, let's solve one more problem on diodes. Here it is asking to calculate voltage and current at various places. So let's go with problem A. And we should remember that these diodes are ideal. These diodes are ideal. That is nothing but in forward bias it is simply a short circuit, in reverse bias it is simply an open circuit. So now let's go with problem A. So problem A we can solve it easily by applying Thevenin's theorem. So let's see how to do it. So first of all, let's decompose this circuit into two parts. So now let us replace the left part of the circuit, the left side of this decomposed circuit with its Thevenin's equivalent. So let's calculate what is the Thevenin's equivalent of this left side of the equation. So VTH, V Thevenin is nothing but clearly 5 over 10 plus 10 multiplied with 10. This is simply a voltage divider equation. Here we will get 2.5 volts. And RTH is simply a parallel combination of two 10 kilo ohm resistors. That is nothing but simply it is a 5 kilo ohm. Now let's replace this circuit, this part of the circuit with its Thevenin's equivalent circuit. So it is 2.5 volt. It is 5 kilo ohm resistor. Here is our diode. Here it is a 20 kilo ohm resistor. Here it is the required value of voltage. This is the current I. This is 20 kilo ohm resistor. So now clearly the diode is in forward bias. There is no doubt about it. So now let's replace the circuit, the diode with its equivalent circuit. That is nothing but a short circuit because it is in forward bias. So clearly here it is 5 kilo ohm resistor, here it is 20 kilo ohm resistor, here it is 2.5 volt. Clearly the voltage V is nothing but the voltage divider equation, 20 over 20 plus 5 multiplied with 2.5 volts. That is nothing but 4 over 5 multiplied with 2.5. Clearly this is 2 volts. And the current I, the diode current I is nothing but 2.5 volt over 5 kilo ohm plus 20 kilo ohm, because 5 kilo ohm and 20 kilo ohm resistors are in series. So the required value of current is nothing but 2.5 over 25 kilo ohm, which is nothing but 0.1 milliamperes. This is the required answers for part A. Now let's go with part B. So here also the same scenario is there. Now let's decompose the circuit into three parts. The first part is the left side one. Here it is clearly 5 volt and 10 kilo ohm as seen before. And the second part is the diode. And the third part is again a voltage divider circuit, but here the voltage is only 3 volts I think. Let's see one more time. 3 volts and two resistors, that is 10 kilo ohm and 10 kilo ohm. Let's replace both the left side of the circuit and right side of the circuit with its Thevenin equivalents. So let's do that. Clearly we had already calculated the Thevenin equivalence. It is 2.5 volt in series with 5 kilo ohm resistor. Let's connect the diode also along with this. Again, the right port of the circuit also, the Thevenin equivalent will not change, that is also 5 kilo ohm, but the Thevenin equivalent voltage will change, that is, it is simply a voltage divider bias, voltage divider circuit. So, it is 1.5 volt. Because both the resistors are equal, that is 10 kilo ohm, 10 kilo ohm, so we are simply taking the voltage across one 10 kilo ohm resistor, that is nothing but the half of the total available voltage. So this is the final circuit. Now we can easily tell that this diode in reverse bias, because anode voltage less than cathode voltage, so there will be no current, so I is equals to 0, and the voltage V we need to calculate. The voltage V across the diode is nothing but 1.5 minus 2.5. Clearly, sorry, here ground connection should be there. The voltage V is nothing but anode side voltage minus cathode side voltage. Anode side voltage, because there is no current flowing across the diode, simply the left side of the voltage is 2.5 volt, that is nothing but cathode voltage, and the anode voltage is 1.5 volts. So it is minus 1 volts. Clearly, by seeing this also we can say that the diode is in reverse bias, because the voltage across the diode is in negative. So the required answer is voltage V is equals to minus 1 volt and I is equals to 0 amps. Thank you. Subscribe.